Yes, hello my dear students, welcome back. I'm Rahul. And in this video, I want to explain you regarding the electrochemistry. Okay, the small video of introduction. Nowadays, you can see that there's a huge demand for the electricity. And we have some traditional methods by that we can produce electricity, like using the wind energy, the potential energy, and even we can use the solar energy. So beyond this, there are some other techniques are there. From that also we can produce electricity. The one important method we can produce electricity, that is using the electrochemical cell. Okay, so let me tell you something very interesting here. Electrochemical cell, electrochemical chemical cell. Okay, this is a device. Okay, this electrochemical cell is a device which interconverts electric energy and chemical energy. Okay, this is a device which interconvert convert electric and chemical energy. So as I am mentioning that electric to chemical energy or chemical to electric energy may takes place, and depending on that factor. So there are two type of main cells are divided, or main devices are there. One is called as voltaic cell. Okay, the voltaic cell is a device, okay, which convert the chemical energy into electrical energy. The device which convert chemical energy to electrical energy. Okay, this is one point. Sometimes this voltaic cell also called as a galvanic cell. This is also called here as or galvanic cell. Okay, and best example for the voltaic cell is Daniel cell. Daniel cell is a best example for the voltaic cell. There is a second device called as electrolytic cell. Okay, so this is also a device which convert electrical energy into chemical energy. Convert electrical energy. You can see the difference here. It is chemical energy to electrical energy is called voltaic cell, and if the cell converting the electric energy to chemical energy, then it is called as electrolytic cell. And lithium batteries are a good example. Electroplating is a same phenomenon that it works. Okay, these are some basic things we have studied. Let's move with the next part, the galvanic cell. We'll detailly study that. The topic of discussion is voltaic cell or galvanic cell. Usually these cells convert chemical energy into electrical energy. The cell which converts chemical energy to electrical energy. So this is what we have. Now we can give an example for this. One of the best example to understand the voltaic cell or the galvanic cell is Daniel cell. That example is Daniel cell. Let's understand what is Daniel cell, how it works, and what are the reactions involved in that. In the Daniel cell, we need two electrodes. Okay, now take it is a zinc electrode, and zinc electrode should be dipped in a container, and that container should be containing the same ions as the rod it is. Means it should have zinc sulfate ZnSO4. Means in the solution state, zinc sulfate can exist at Zn plus 2 and SO4 minus 2. And along with that, we need one more electrode. This is another electrode, and this is copper electrode. Now this copper electrode you have to dip in a container, and that container should contain the same kind of ions as that of rod, that is copper sulfate it should be. It means that when the copper sulfate is dissolved in a container, it is exists in the copper plus 2 oxidation state and SO4 minus 2. Now these two electrodes are externally connected through a galvanometer or voltmeter. Better take galvanometer. This is the basic construction of the Daniel cell. I am not mentioning here the U-shaped tube which connect these two solutions. Okay, So let it be. I will explain that in the later part because we need to explain, we need to understand the basic, the reaction patterns here. Here, it's a natural tendency when zinc is in contact with its own ions or Zn plus ions, then zinc start dissolving. Okay, let me write the first point. Zinc starts dissolving, and by that what happens? It liberates some electrons by giving electrons. And because of that reason, here in the beginning, whatever the concentration of Zn plus 2 is there, it go on increases. Okay, concentration of Zn plus 2 ions in the solution increases. The solution increases, the concentration get increased here. Second point, the electron given by the zinc, they travel here in this direction. Okay, let me write those two electrons here. The electrons are traveling in this direction and they reach copper rod. The now copper rod accumulated by the electrons and surrounded by copper plus 2 ions, Cu plus 2 ions and SO4 minus 2 ions. Now out of these two, as this entire electrode is negatively charged because electrons are reached here, therefore copper get deposited. Okay, so therefore you can say that in the second part, the copper starts depositing by taking 2 electrons. Okay, so this is the first step. If it is understood, then we go with the next information. As we are added here a salt, in the salt you should know that whenever the salt is dissolved, the number of cations produced is exactly equal to number of anions produced. Therefore solution is electrically neutral. But when zinc start dissolving in the first step, the zinc atom or zinc ion is dissolved here as a Zn plus 2, the concentration of Zn plus 2 ions increases. Okay, therefore this entire solution is get positive charge. Okay, so as it gains a positive charge, the next time when a zinc want to dissolve in its solution, it will not happen because already the solution is positively charged and the new Zn plus 2 ion is also positively charged. There is not a possibility, there is a repulsion takes place, and therefore the next Zn plus 2 is not going to dissolve. This is the one part of the explanation. I repeat once again, as the Zn plus 2 is dissolved in a solution, the concentration of Zn plus 2 increases, and by that we can say that the entire solution is positively charged. The electrical imbalance takes place. At that moment, if we try to dissolve another zinc plus 2 ion, it is not possible because there is a repulsion between positive and positive. This is one part of the explanation. Come to the other part. Think about the copper here. Now copper get deposited, and because of that reason, let me write this point. Copper start depositing by taking 2 electrons, and concentration of Cu plus 2 ions in the solution decreases. In the solution it is decreases. It's the first time when the copper plus 2 is deposited. Again this entire solution becomes electrically negatively charged because the SO4 minus 2 ion concentration is more in the solution because copper plus 2 is get deposited. It removed off. Therefore only leaving behind that SO4 minus 2. Therefore this solution become negatively charged. Let me write this. This solution is negatively charged. Okay, and this solution, the copper zinc solution, is positively charged. Okay, to overcome this problem, we use a tube called as a salt bridge. Let me draw that salt bridge here. The salt bridge is U-shaped tube. It looks like here. I'm just drawing the U-shaped tube, and in this tube it contains, this is first, let me write, this is salt bridge, and this salt bridge is containing ammonium nitrate, that is NH4NO3, or KCl or KNO3, any of the salt which is sparingly soluble, easily soluble in a liquid or in a water. Now this compartment, or you can say zinc plus 2 ions are more here, and therefore in this direction, if I take here KCl, the 2 Cl minus ions will come out of the U-shaped tube. And now this positively charged solution is, it get neutralized. It get neutralized. Now on this side, in this side, the 2K plus ions will dissolve, because here SO4 minus 2 ions are mono. Therefore this time this negatively charged solution is, it get neutralized. This neutralization process is done by the salt bridge. So salt bridge neutralizes the solution. Neutralize the solution, providing respective ions in that. Okay, that's one part. So this is all about the parts, some parts of explanations here regarding Daniell cell. Okay, in this we have to study how the electron is moving. You can notice here that the electron is moving from zinc to copper. Let me write that point. Electron is moving from zinc to copper rod. Okay, copper rod. That we can observe in a galvanometer. Okay, so that we can see in a galvanometer. So electron is moving from zinc to copper through galvanometer. And it says that it gives information regarding in which direction the electrons are moving and how much extent the EMF, the voltage, is produced. And by conventional method, or by convention, the direction of electric current is copper to zinc. That is direction of current is from yes, that is from copper to zinc rod. Some students get confused that the electrons are moving in the direction of zinc to copper. In that direction only the current will move. No, by conventions we have made the direction of current is opposite to that of the flow of charges. Okay, now so this is the entire thing, that working of the Daniell cell. Next video I will explain how the Daniell cell reactions are taking place and what are the terminologies related to the Daniell cell. Let's see that. It's a previous video where we studied the construction and working of the Daniell cell. So this is what we explained in the previous video, and go and check in the link. Now in this video I'm going to explain that what kind of chemical reactions are taking place in a Daniell cell. The first of all, when we talk about Daniell cell, there are two electrodes are used. Usually two electrodes are used here. The one is zinc electrode, which start dissolving. Initially it is solid, and it start dissolving means it should carry some charges. You should know that only charged particles or ions get dissolved in a water. So therefore I will write here Zn plus 2, and that get dissolved in aqueous medium and leaving behind 2 electrons. Here zinc lost electrons, and therefore we can call it as oxidation process, oxidation reaction. Now in the second case, the copper, which is already dissolved in a solution and start depositing, means copper is dissolved means it is having a +2 oxidation state, and the state is it is present in the aqueous medium, and it get deposited. It means that it is consuming 2 electrons. When it consumes 2 electrons, it get converted into copper, and that is in the solid state. Now you can see that the copper is gaining electrons. When the copper gains electrons, then this process is called as reduction. Okay, the oxidation and reduction process are taking place in a Daniell cell. By conventional way, we can combine these two equations. Let me combine these two equations. The common terms get cancelled. That is, 2 electrons are get cancelled here. Okay, the remaining things we're going to write here. Zinc solid reacting with copper +2, which is aqueous medium, gives here the product Zn plus 2 aqueous, and then we get copper in the solid state. Now we have to use some terms here. The electrons where they are produced, they are called as anode electrodes, or the process of oxidation takes place, that point is called as anode. The oxidation place is called as anode. Therefore, this is called as anode reaction. Anode reaction. At the anode, always oxidation takes place. Why we are using the anode term here? Because only one thing, that the electrons are produced. The anode is negatively charged here. Negatively charged. And because of that reason, we given the name. Okay. And the second reaction, obviously, it should be cathode reaction. Cathode reaction. But why cathode here? The cathode, because here reduction is taking place. The electrode is electron deficient. So it is surrounded by cations. So it is hungry for the electrons. So therefore, it carrying here positive charge, or positively charged it is. Positively charged. Okay. The anode reaction is always oxidation. Cathode reaction is always reduction. And therefore, again, there is a new term is produced. This is called as anode half cell, because here only the half of the reaction is taking place, and at the copper, or you can say that cathode, the half reaction is taking place, and therefore you can say that, so this is a half cell reaction. Half cell reaction. And here also, for the reduction also, we can write half cell reaction. Half cell reaction. Half cell reaction. And whatever the complete reactions we wrote for anode and cathode, the combined reactions are called as the cell reactions. Cell reaction. Hope you understood this. Now another part, the electrode, we have to assign the signs. Okay, sign for electrodes. Okay, very simple it is. Already known thing is that, as I mentioned, that oxidation is taking place at the anode. Because of this, the electrode gains negative charge. Okay, therefore anode electrode is negative. Okay, and cathode electrode is positive. That should be positive. Hope you understood this, right? So these are some basic terminologies used in the Daniell cell, and this is the chemical reactions taking place in a Daniell cell, students. Okay, in the next part, I'm going to discuss the electromotive force, very important concept, and after that we'll study the single electrode potential and origin of single electrode potential. Let's see what it is. Yes, welcome back. So today's topic is electromotive force. Most of the students have confusion regarding this. I decided to make a simplified video. Okay, let's understand this. Now I have electron here, which is negatively charged, and there is a point here. I will refer this point as A, and somewhere at the certain distance there is another point, so here, and I refer this point as a B. In a solution, or in a container, or even in the metallic rod or metallic conductor, the electrons are moving in random directions. To bring them in a particular direction, we need certain force. We have to force the electron to move in a particular direction. And for that, what I'll do that, by hypothetically I just believe that, so somewhere here there is a positive field is there, the positive charge, somewhere some wall is there, the positively charged wall is there. And therefore, at this wall, the positive charge is high at the point B. Therefore, high charge, high potential. I call it the potential. High potential. Charge potential is high at the point B because it is very close to the B. Now, as you move away from the B or away from the wall of positive charge, the strength of the positive charge go on decreases. If you reach at the point A, the strength of positive charge or strength of potential is low. Therefore, I will write here low potential. Low potential. Now, as the electron is negatively charged and wall is positively charged, the electrons start moving. Let me select this and let me show you how it's moving. So this is how the electron is moving in this direction. So why it is moving? It is moving because in this direction at the B there is a wall which is positively charged, electron is negatively charged, and therefore electrons start moving towards B. Okay, so if I ask you a question that from which potential to which potential electron is moving, you will say that the electron which is present at the low potential is moving toward the point at high potential is present. So therefore we can say that the EMF, before we start the discussion, so here the electron is moving moving from a low potential to high potential. Okay, this one point we listed here. Now, as I mentioned and explained in the previous video, that by a convention, we consider that the direction of current is opposite to that of the flow of electrons. Now, if I write here the flow of electron moving from A to B, this is the direction for the flow of charge. Now, the flow of electric current, it is opposite, that is from the B to A. That is, this one indicates the flow of current. Okay, so now the red line indicate that flow of electrons, or flow of charge. I will write flow of charge, or direction of the charge and direction of current. Now if I ask you that current, how it is moving from B to A, include the term potential. In that case you will say that is the flow of current from higher potential, the B having here higher potential. This is the initial point. Electric current is started here and moving towards the A. The flow of current from high potential to low potential. You can see that at the A it's a low potential, low potential. Okay, hope you understood this part. And for bringing this change, to bring the electron from A to B, or to carry the current from B to A, whatever the wall of positive charge or whatever the force you are using here, this force itself is called the EMF. EMF is nothing but the potential difference. Let me write that point. Okay, the EMF is the potential difference. This is the definition. The potential difference, PD I will write, potential difference between two electrodes. Between two electrodes I will take, because here the points I have taken, I will write here two electrodes of galvanic cell, that force, the potential difference causes flow of current, that is electric current, flow of current from low potential to high potential, okay, and it is also called as a EMF of the cell or cell potential. Okay, EMF, or you can call it called as cell potential. Hope you understood the concept of EMF. Okay, the direction of the electric charge is different and direction of current is different, but when we expressing the EMF, you have to consider the either charge or either electric current. Both the definitions you can include. Okay, now we'll see some factors which decide the EMF of the cell. The EMF of cell depends on few factors. Okay, EMF of cell depends on few factors. Depend on few factors. So let me list out those few factors here. The first factor is the temperature. So as you know that when you rise the temperature, the atoms are started moving, the flow of charge become fast, and because of that reason what happens here? Yes, conductance or potential difference increases and the flow of current is also increased. Second one is, in a Daniell cell we have taken two beakers, and in that we have taken copper sulfate and zinc sulfate solution separately. Their concentrations we assume it's a 1 molar, but if you change the concentration, then also the EMF get changed. Therefore the concentration concentration, concentration. And lastly, the one and very important, the nature of the electrode. Every atom in the periodic table in different oxidation states have tendency to gain electrons or give the electrons. They have different tendencies. When you combine different electrodes of different tendencies, we'll get different EMF values. So therefore we can say that, so nature of electrode, nature of electrodes, electrode. Okay, so this is all about the EMF of the cell. In the next a small video, I will explain that how the EMF of the cell is related to the thermodynamic term Gibbs free energy. That will be a very short video but very informative. Let's see that. Yes, welcome back again. So the topic of discussion is a relationship between the EMF and delta GR. As in the previous video, I was successfully explained the what is EMF. Okay, but the fact is the EMF is a driving force for the cell reaction. Okay, so let me write that point first. The EMF is driving force for cell reaction. What is the meaning of this? The meaning is very simple, students. If there is a EMF, then only the cell reaction takes place and production of electricity takes place. If there is no EMF, there is no the production of electricity takes place. And that we're going to relate with the Gibbs free energy of a reaction. Okay, how it is? We have an equation that is delta GR Gibbs free energy for a particular reaction is given by minus negative NEF, where delta GR is Gibbs free energy, free energy for cell reaction, then N is number of electrons taking part in a redox reaction or chemical reaction. As in the Daniell cell, the value of N is 2 because 2 electrons are flowing from zinc to copper. Therefore, N is number of electrons. Number of electrons. Now, F is Faraday constant. The greatest scientist, the Faraday, and E is the EMF. Now, you have heard that spontaneity and non-spontaneity of a reaction. Spontaneity means the reaction or the process which is taking place itself without consuming any of the external energy or external force or external help. The cell reaction, in that, if the reaction is spontaneous, it is taking place its own without external energy. In that case, the electricity is produced by its own. Okay, so therefore we can say that the cell reaction is spontaneous. The requirement is the cell reaction should be spontaneous. To produce electricity. Otherwise, what happens? The given reaction is non-spontaneous. To make that reaction spontaneous, you have to spend energy. And after that, the reaction becomes spontaneous by gaining the energy and produces electricity. It have no meaning because you have spent some amount of energy and produced some amount of electric current. So there is a loss of energy takes place. So therefore, the cell reaction which is producing the electricity, that reaction should be a very spontaneous. This should be clear. Second point, for the spontaneous reactions, the delta GR value should be always negative. For spontaneous reaction, delta GR Gibbs free energy, always it is negative. Okay. Now, the EMF may be positive or negative. It is greater than 0 or less than 0 it is. But if I take here delta GR is equal to minus N minus E and F, and you will get here positive value. the EMF never be negative here. So therefore, for a cell reaction, for a cell reaction, the EMF should be always positive. The EMF should be always positive. This is the important point, students. You may get such questions in competitive. The EMF of the cell should be always positive for a cell reactions to bring the electricity. Now, so if you put here delta GR is equal to minus n, that negative sign will be there in our original equation. Then E, that is a positive quantity, F is also positive quantity, and the entire equation becomes negative. If delta GR is negative, then the reaction becomes spontaneous. If the reaction is spontaneous, then it produces the electric current. So therefore, we can say that the few important points, the one is the cell reaction should be always spontaneous. For the spontaneity, the Gibbs free energy should be negative all the time. To bring the Gibbs free energy negative, the EMF of the cell should be always positive. Remember this, EMF of the cell should be always positive. The positive value of EMF indicate that the spontaneity of the cell reaction and in the given direction. Right. This is all about the relationship between the EMF and Gibbs free energy of a cell reaction. Hope you understood this. In the next video, I'm going to make a small explanation on single electrode potential. And after that, I will explain how the single electrode potential is produced. And that is the only concept on that the Daniell cell or entire voltaic cell concept is dependent. You may ask a question that zinc liberates the electrons, copper consumes. Why not copper liberates the electron and zinc consumes? And that we can explain using the single electrode potential. Let's see. Thank you for watching this video, students.